Well, hey everybody, Mr. Reeves here to do some practice problems with you on lesson 7.1, writing and solving one-step inequalities. All right, let's go ahead right now and dive in and do some of these problems. Remember, when you're solving a one-step inequality, you are going to use inverse operations just like we did with one-step equations. All right, but we do have to remember if we multiply or divide by a negative, we do have to reverse the inequality sign. So right here, I've got n minus 5 is greater than or equal to negative 2. The inverse of subtracting 5 is adding 5. And when I do that, I get n is greater than or equal to 3. I do not have to reverse the inequality sign because I added a positive number. In fact, you can add any number, positive or negative, and not reverse the inequality sign. So n is greater than or equal to 3. I'm going to go ahead and put a closed circle on 3, and then I'm going to put an arrow going to the right. That's where we are greater than or equal to 3. All right, let's do this next one. 3 plus x is less than 7. Well, the inverse of adding 3 is going to be subtracting 3. And when I do that, I get x is less than 4. Again, no need to reverse the inequality sign. All right, I'm going to go to 4. I'm going to put an open circle because 4 is not included because it's just a less than symbol. And since it's less, I'm going to go to the left. That's where the values are less. All right, this one right here, negative 7 times y is less than or equal to 14. This time I'm going to divide by negative 7 because that's the inverse of multiplying by negative 7. But since I divided by a negative, I must reverse or flip that inequality sign. So I get y is greater than or equal to. It was less than or equal to. Now it's greater than or equal to negative 2. So I'm going to put a closed circle on negative 2 because it's greater than or equal to. That equal to makes the circle closed. And then the arrow is going to go to the right. All right, what about this one? B divided by 5 is greater than negative 1. I'm going to multiply by 5 because the inverse of dividing by 5 is multiplying by 5. And I get b is greater than negative 5. I do not reverse the inequality sign because I multiplied by a positive. All right, negative 5 is going to be an open circle because it doesn't have the equals. And greater than is going to go to the right. All right, there's some examples of one-step inequalities. All right, I would like to do this one right here, number 13. I want to talk about this negative here. I think I've told you before, when you have a fraction with a negative, all right, you could put the negative in the numerator, you can put the negative in the denominator, or you can put the negative out front like they did here. It all means the same thing. Now, my recommendation to you when you're solving an inequality is to go with this one right here. Go ahead and move that negative down to the coefficient, or in this case, the number we're dividing by, because then we'll be left with a positive q. So I'm going to think of this as q divided by a negative 7. Well, the inverse of dividing by a negative 7 is multiplying by a negative 7. So those will cancel, right? And I will get q, but since I multiplied by a negative, I'm going to reverse or flip that inequality sign. Q is less than or equal to positive 7. Okay, so there's my circle. I'm going to color it in because it's got the equal to on it, and I'm going to shade to the left. One more here again, negative 12 times x is 60. The inverse of multiplying by a negative is dividing by a negative. Since I divided by a negative, I'm going to reverse the inequality sign. And 60 divided by negative 12 is negative 5. Again, reverse the inequality sign when you multiply or divide by a negative. Not when you add or subtract, or if you multiply or divide by a positive. All right, greater than negative 5. There's my open circle on negative 5. And my arrow goes to the right. Okay. All right. Let's do a few word problems here. All right. Let's look at number 17. It says the vet says that Lena's puppy will grow to be at most 27 inches tall. All right, Lena's puppy is currently 1 foot tall. How many more inches will the puppy grow? All right, so we need to know that at most means less than or equal to. It's at most 28 inches. It could be 28. It could be 27. It could be 24 and a half. All right, so Lena's puppy is currently 1 foot tall, plus however much more it's going to grow. X is the additional growth. Okay, X is going to be the additional growth. So 1 plus X is less than or equal to 28. If I take away that 1, I get X is less than or equal to 27. So how many more inches will the puppy grow? Well, it will grow at most 27 inches more, right? Or we could say 27 inches or less. All right. Okay. Each of 7 kittens weighs less than 3.5 ounces. Find all the possible values of the combined weights of the kitten. So each kitten weighs less than 3.5. So 7 times 3.5, right? Well, they weigh less than that, right? So find all the possible values of the combined weight in kitten is going to be less than X, all right? 7, actually, let me write this instead. X is less than 7 times 3.5. If we had done equals, that would assume they all equal 3.5, but X is going to be less than 7 times 3.5. All right, so if I do 7 times 3, that's 21. Half of 7 is 3.5, so 24, actually, let me say this, less than 24.5 ounces. Or we could say, all right, no, it has to be less than 24 because it's not equal to. All righty. Okay, here, let's go ahead and do this one, number 20. To get a free meal at his favorite restaurant, Tom needs to spend $50 or more at the restaurant. $50 or more, that's going to be greater than or equal to 50. All right, he's already spent 30, 25. How much more does he need to spend? Well, that's going to be our X, the amount he needs to spend more. So we've got 30.25 plus X has to be greater than or equal to $50. All right, so I'm going to go ahead and subtract 30.25. That's how much he's already spent. So X is going to be greater than or equal to, well, let's see, 50 minus 30, that would be 20. So 1975. All right, so how much more does he need to spend? He needs to spend $19.75 or more. Or we could say he needs to spend at least $19.75. All right, how about this one right here? And we'll finish up with this. All right, the sign shows some prices at a produce stand. Selena has $10. Okay, that's the maximum she has. What is the greatest amount of spinach she can buy? All right, well, spinach is $3. All right, so 3 times X has to be less than or equal to 10. Well, if I divide by 3, I get X is less than or equal to 10 thirds, all right? Or if I make that a mixed number, you guys know I'm not a big fan of mixed numbers, but if she's buying things, well, 3 goes into 10 3 times. 3 and 1/3. These are pounds, right? LBS, did you know LBS stands for pounds? All right, Gary has enough money to buy at most 5.5 pounds, at most less than or equal to. How much money does Gary have? All right, we're looking at potatoes here. So we've got 5.5 times 50 cents. All right, so what we want is half of 5.5. All right, well, half of 5 is 250. And half of 50 is 25, so 2.75. All right, since he has at most that, so it's he has $2.75, right? Or if he's going to buy at most that 5.5, how much money does Gary have? Actually, he has 275. That's the most. Okay. All right, last question. Florence wants to spend no more than $3 on onions. No more than means less than or equal to. Will she be able to buy 2.5 pounds of onions? All right, well, onions are $1.25. So if I do $1.25 times 2.5, the question is, all right, is that less than or equal to 3? All right. Well, let's do this. 1.5 times 2, again, if I just do 1.5 times 2, that's 250. All right. If I do a half of $1.25, well, let's see, a half of $1 would be 50 cents. And then a half of 25 would be 12.5 cents. Well, you could see that if I add those together, those two right there, that's going to give me $3. So the answer is no. All right, will she be able to buy? No. All right, it costs more than $3. In fact, it cost $3.12. Okay, by the way, I did not use a calculator on any of these problems. You are welcome to use a calculator. All right, so that is some practice problems from lesson 7.1 on writing and solving one-step inequalities. I hope this was helpful. Until next time, have a great day.